All right, continuing our examples with implicit differentiation. First thing is we want to find the graph for this thing. I can't call it a function because if we look at it, it's like an alien, right? So like you see little eyes and you see the head and you see the ears and the radio waves coming out of its ears. It's communicating with all the other aliens. I joke, but it's kind of an interesting thing. We have to call this a relation because it does fail the vertical line test. Well, either any way you split it. So it is not a function, but we can still find the derivative of this thing, how quickly it's changing at a certain point, right? That's really what the derivative is saying. So if we want to find dy dx for this given function, right, I would have to, okay, I want blue. Colors. I would need to take this and find its derivative, right? So if I now work on the left-hand side, right, so derivative of sine is cosine, and then I would leave the inside alone according to the chain rule, and then multiply by the derivative of this inside piece here, so 2x would be the derivative of x squared plus 2y times y prime. Let's change that to dy dx to be consistent with what they're asking for. And I think that's it on the left-hand side. The right-hand side is then, let's see, this is a product, right? So 1 d2 would be negative sine of x plus 2 cosine x d1 2y times dy dx. Okay, and I need to solve for dy dx. Yes? Okay, let's do it. So, okay, this is fun. Let's see, the algebra is a little complicated here. What we actually have to do is, on the left-hand side, we have to distribute everything. Ugh, doesn't that sound fun? Okay, 2x. We're building character cosine x squared plus y squared plus 2y cosine of x squared. Oop, that's messy. X squared plus y squared. Y squared. Dy dx. Is equal to, and then we have, let's see, we're going to have a cosine, let's write this a little bit differently, 2y cosine of x times dy dx, and then minus y squared sine of x. Okay, and now I'm going to skip a few steps. If you rearrange and solve for dy dx, okay, you'd need to, let's see, you'd need to move, let's see, how are we going to move this around? We're going to move the 2x cosine x over by the y squared sine x. So this would be negative 2x cosine x squared plus y squared. And then minus y squared sine of x. Okay, and then on the other side I'd have to move this 2y cosine x to the other side, factor out the dy dx, and then divide it all over. So then that actually puts the denominator as 2y cosine of x squared plus y squared, and then minus 2y cosine of x. Okay, and so it's a little messy, a little complicated algebraically, but there you go. So that's how the alien graph is changing at a certain point. Okay, and you would just need to find that point and sub it in, right? All right, so this next example, okay, doesn't look terribly complicated, right? We just have to find the second derivative. It shouldn't be that bad, right? Well, let's see. So I'm going to say if we do the first derivative on our own, right, we could probably do that. So 4x cubed plus 4y cubed times y prime is equal to 0. Okay, solve for y prime. And so if I solve for y prime, I would just get, okay, subtract the 4x cubed over, and then the 4y cubed would go in the denominator. So then, that's 4y cubed. Let's see, that's a minus. There we go. And if I reduce a little bit, I get negative x cubed over y cubed. Okay. Not terrible, right? And that's y prime. Okay. And actually, let's just make that change here, and then I don't have to worry about double equal signs. Okay. So then, y double prime. Not that hard, right? You just have to differentiate the derivative. Okay. So then, if I differentiate the left-hand side, Okay. This would just give me y double prime. Oh, okay, that's easy. And then now, okay, over here, oh, that's a quotient, isn't it? So I have to do the quotient rule. Okay, so let's, for simplicity, let's put the minus with the x, just so I don't forget about it. So let's see, I do low d high, so it'd be negative 3x squared, plus high, negative x cubed, sorry, minus high, d low, okay, so then this is 3y squared y prime. Oh, the derivative comes back in. Okay. And then over low squared. Okay, so this would be y to the 6th. Okay. Okay, so that looks annoying. But we can see it. I mean, honestly, this answer would be okay other than the y prime. Yeah, we need to replace that with what we know y prime is. Okay, so we can't just drop it and go. So if I rewrite this, I'd have negative 3x squared y cubed plus 3x cubed y squared times, and then I'd have a negative x cubed over y cubed. And then all over y to the 6th. Okay. Now this would be better if you wanted to simplify it further. You could. Let's see. I'd have negative 3x squared y to the 4th. I'll explain this in a moment. Minus 3x to the 6th y, or 3x to the 6th. I'm sorry. All over y to the 7th. Okay, so algebraically speaking, right, like these reduce and I have another y in the denominator, so what I did is just multiply numerator and denominator by y, so that's why I have 7 in here, and then that increased from y to the 3rd to y to the 4th. Okay, so that is how that all reduces. Okay, so there you go. Not terrible. Okay, but again, when you're doing the second derivative, be on the lookout for that y prime appearing again, and if you've already solved it, you need to resubstitute for it. That's the big takeaway with this one. Alright, next video will be our last video, just looking at orthogonal curves and how we can find their rates of change.